So we are going to have a Fourier series for the function Fourier series for an arbitrary period 2L. P is equal to 2L, where L is the length of the vibrating string. If the string is fixed and you just lift it and move it, leave it, so it begins to vibrate. That is the vibrating string. Its length is going to be L, or length of the rod in heat conduction. So these are the things you are studying in partial differential equation. We have discussed if period P is equal to 2 pi, we have defined the Fourier series of the form A0 plus A1 cos x, B1 sin x plus A2 cos 2x, and so on and so forth. And we have seen each term is having period 2 pi. If it is going to be moving, we are having B 1000, sin 1000 x, and so on and so forth. We'll see still each term having period 2 pi. The constant function does not have their own, so they can have the period of their fellow members, whatever it is. So its fundamental is pi, but its 2 pi is also a period. Because we have seen if P is a period, then NP, where N is an integer, is also a period. Similarly, this term, sin 1000x having period 2 pi. Because if you are calculating fundamental will be 2 pi by 1000. So if you multiply with an integer which is 1000, so I will get 2 pi. So this is the series defining for 2 pi. Can you define a series with period 2L, where L is the arbitrary length? It might be 2, 4, 600, whatever it is. Let me have the series of the form A0 plus sigma n equal to 1 to infinity an cos n pi x by n plus bn sin n pi x by L. This is the series for the arbitrary period 2L. If I am suppose writing sin pi x by L, and I wish what is its period, what you are going to do is, we have 2 pi divided by A, and A is your pi by L. Let you divide by pi by L. So it becomes pi cancel, you are getting 2L. So this is the way you can define a series. It is going to be sine, for example, sine 100 pi x by L, suppose. Because this is a trigonometric series, infinite terms are there. Because sigma is 1 to infinity, there are infinite many terms. One term is suppose sine 100 pi x by L. Can this have period 2L? Let's see. It is going to be A. So we have a formula to, if f of x having period P, then A of x, f of ax P by A, 2 pi by this A, which is 100 pi by L. This I am dividing. So this becomes pi goes, it becomes 2 by 100, and this L goes there. So this is 2L by 100 is the fundamental, the smallest period of sine 100 pi x by L. How to make it 2L? So if I multiply with an integer which is 100, so I will get 2L back. So this is the situation, each term on the right hand side having period 2L, because I would like a function whose period is 2L. So the series is going to be this. So you have to notice each term, if you are writing couple of terms, and you will see each term having period 2L, and the constant will attain the period 2L. Now A0 and AN and BN are the Fourier coefficient, which are going to be like this, minus L to L fx dx, where the L is replaced by pi. So AN is 1 over L minus L to L f of x cos n pi x by L dx. This is your AN. And then BN will be 1 over L minus L to L f of x sin n pi x by L dx. So there when we were discussing 2 pi, so it is cos nx dx, but here we are discussing 2L period, so the coefficient are a, n and b n are n pi x by L, where L is the given length, which is given 2, 4, 6, 8, 10. So make sure you should understand that if you are writing this in terms of a series, each term having period 2L, according to the definition, if P is a period, then NP, if you are multiplying with an integer, you are getting 2L each time. You are getting 2L. So this is the series for arbitrary period 2L, where A0, AN and BN are the Fourier coefficient. And note, if the function is even, odd, neither even nor odd, according to which we have done in 2 pi, you are going to have the same thing here. Applying the property, and Fourier, if the function is even, Fourier cosine series, calculate A0 and AN. If the function is odd, calculate only BN. So through an example, couple of examples we'll discuss and see how we use the definition of an even or odd function and how to find the Fourier series. Let me have a sketch there. This is -2, -1, 0, 1, 2, and this is something k. This is on x-axis. This is going to be 0 and this is going to be 0. Look at that. The function is given, find the Fourier series. And you see from -2 to 2, this is P is equal to 2L is equal to -2 to 2, the total length is 4. It means L is equal to 2. So this you have seen from the graph. And since the function is periodic, this graph moves backward and forward. So you have to determine length of the interval yourself. -2 to 2 is 4, 2L. 2L is 4, so L is 2. Since the graph is symmetrical about y-axis, it is an even function. Even function, so the Fourier series for an even function can be written n is equal to 1 to infinity an cos n pi x by L. This is the series. For an even function, we have to calculate two coefficients, A0 and AN, and Bn automatically 0. But if you wish to calculate Bn, it will be 0. So these are the coefficients. And A0 is 1 over L 0 to L f of x dx. Look, there we were talking about 2 pi period, 1 over pi 0 to pi, here the arbitrary period, which L is the length. We do not know what is the length. So 1 over L 0 to L, because even, function is even, we have the property. So L is replaced by 2, 0 to 2, f of x dx, because this L is 2 now. Now 0 to 2, once the limit are 0 to 2, look at the graph. Look at the graph. And you are not going to write 0 to 2 it is k, because 0 to 1 it is k and then 1 to 2 it is 0. So split up the graph. Half is taken out, let 0 to 1 and 1 to 2. Because the definite integral have the property to make partition as many as you wish. Here we are going to do 0 to 1 it is k. 1 to 2 it is 0. Look at that. Once you integrate, it is k by 2. K by 2. So its integral is x and upper limit is 1. So it is k by 2 is your A0. A0 is your k by 2. Let me calculate AN. AN is 2 by L 0 to L. F of x cos n pi x by L dx. This is the formula for an even function. I have applied the property. It was 1 over L originally. But since f of x is even, cos already even, the product of two even function is even, let the lower limit is 0 and integral is multiplied by 2. This is good. So 2 by L is 2, 0 to 2, f of x cos n pi x by 2 dx, replacing L by 2 everywhere. Whatever it is, don't bother about it. It is 1, 2, 3, 4, 5. So 2 goes, it is 0 to 2. Now 0 to 2, the graph is 0 to 1, which is k cos n by x by 2 dx plus 1 to 2. 0 to 2 you have split up. 0 to 1 and 1 to 2. 1 to 2 the graph is 0. We are calculating now an. An is k is outside. This k is outside and I am integrating, which is sine n pi x by 2 divided by n pi by 2, and the limits are 0 to 1. Yes, limits are 0 to 1. So this can be written 2k by n pi. This whole is going to the numerator, 2k by n pi, and upper limit on x, because the variable of integration is x. So the limits are on x. X is replaced by 1 sine n pi by 2, and the lower limit is 0. Sine 0 is 0. Now sine n pi by 2, you are not going to write it 0, because when n is 1, sine pi by 2 is 1. When n is 3, sine 3 pi by 2 is minus 1. But when n is even, 2, 4, 6, it vanish. So this will be 0 if n is even. If n is 2, 3, n is 2, 4, 6, 8. So that cancel, you are getting n pi. N pi being 1, 2, 3, 4, 5, that vanish. N is even. So this is an we are calculating. So I am calculating a1, a3, a5, a7 and so on and so forth. N is 1 everywhere. N is 1. Sine pi by 2 is 1. So which is 2k by pi. N is 1. N is 3. 3 pi by 2 sine is negative. Minus 2k by 3 pi. N is 5. 5 pi by 2 sine positive. 2k by 5 pi. Then n is 7. 7 pi by 2 sine is negative. Minus 2k by 7 pi and so on and so forth. So this is the idea you can have. You are not going to take it to 0. It is going to be 0 when n is 2, 4, 6, 8. So you have to calculate odd. The required series is. The required series f of x is equal to a naught plus a1 cos pi x by L, L is 2, plus a3 cos 3 pi x by 2, plus a5 cos 5 pi x by 2, and so on and so forth. Because for even I am not calculating because it is going to be 0. So a naught is k by 2. A naught is k by 2 plus, what is A1? A1 is 2k by pi. 2k by pi cos pi x by 2. What is A3? Minus 2k by 3 pi. Minus 2k by 3 pi cos 3 pi x by 2. What is A5? 2k by 5 pi. 2k by 5 pi sine 5 pi x by 2 and so on and so forth. So this is the required Fourier series for the function which is given in this diagram with the arbitrary period. 2L is 4, so L is 2. So sketch the function and find its Fourier series. This time I have given the function. You have to sketch, see whether it is even, odd, or neither even nor odd. According to that, you have to calculate the Fourier series. Let me sketch the function. This is x-axis, this is -4 and this is 4. When x is -4, f of x is -4 here. When x is 0, it is 0. When x is 4, it is 4 here. So let me, this is going to be, so this is the function this time. F of x is x, which lies between -4 to 4, is this function. It means P is equal to 2L is equal to total length. What is the length from this to this? So this is 8. This implies L is equal to 4. So since the function is an odd function, it is symmetrical about origin. So we have Fourier sine series. Fourier sine series, we are writing Bn sine n pi x by L, where n is equal to 1 to infinity, trigonometric function, infinite series. So do not mix it with pi. For the pi series is sine nx, for L arbitrary period n pi x by L. So this is going to be the difference. Bn will be 2 by L 0 to L, f of x sine n pi x by L dx. This is the formula we have derived by using the property of even odd function. If it is odd, sine already odd, product of two odd is even, let the lower limit is 0 and the integral is multiplied by 2. L is replaced by 4. 0 to 4, f of x sine n pi x by 4 dx, replacing L by 4 everywhere. Now 0 to 4, the function is this, which is x, because a continuous function. 2 by 4 is half. 0 to 4, it is x sine n pi x by 4 dx. This is going to be the function. Now we are using the tabular integration over it to integrate this. This is x, this is sine n pi x by 4. If you are using tabular integration, make sure the polynomials are written on the left hand side, whose derivative eventually vanish. The derivative and the integral 4 over n pi cos n pi x by 4. And the derivative 1 0, integral of this minus 16 by n square pi square sine n pi x by 4. This is the tabular integration we are having. This and this. Put a plus in minus. Now from the table you will see the limits are 0 to 4. If I am applying 4 over here, over x, 4 goes sine n pi, that's 0. And if the lower limit is 0, so that vanish. It means this part is going to be 0 by upper lower limit. When x is 4, this 4 cancels, sine n pi 0. When x is 0, sine 0 is 0. We are left with that. This is the part we have left. So let me write half is there and minus 4 over n pi there, x, cos n pi x by 4, the limit are 0 to 4. Look at it. So we have this. Now 2 to the 4, minus 2 by n pi there. Limit are on x. X is replaced by 4 everywhere. This is 4 cos n pi 4 by 4. And the lower limit, this x is 0. So it is going to be 0. So this is minus 8 over n pi outside. This 4 goes. Cos n pi again minus 1 raised to the power n. minus 1 raised to the power n is your cos n. So we have for an odd function, we have calculated only bn, which is this. So b1, b2, b3, because it is not going to be 0, b1, n is replaced by 1 everywhere. So this is 8 over pi. N is replaced by 2 everywhere. So minus 1 square is positive, minus 8 over 2 pi. B is replaced by 3, n is replaced by 3 everywhere. So 8 over 3 pi. N is replaced by 4. So minus 8 over 4 pi. N is replaced by 5. So 8 over 5 pi, and so forth. The required series I am writing b1 sin pi x by L is 4, plus b2 sin 2 pi x by 4, plus b3 sin 3 pi x by 4, plus so forth. This is the series I have written, b1 sin n1 pi x by L is 4, plus b2 plus b3, so and so. So I have calculated the coefficient. Let me put the coefficient. 8 over pi, b1 8 over pi sin pi x by 4. b2 is minus 8 over 2 pi sin 2 pi x by 4. b3 is 8 over 3 pi sin 3 pi x by 4, and so forth. So you can take something common. If you can simplify a few more steps, 8 over pi is taken out. 8 over pi is taken out, you are left with sin pi x by 4, 8 over pi, minus half sin 2 pi x by 4, plus 1 by 3 sin 3 pi x by 4, and so forth, which is the required Fourier series for the function odd whose period 2L is equal to 8. We have seen from the graph. So these are follow-up written. I have just finished the Fourier series for the arbitrary period p is equal to 2L. A couple of follow-ups are there, so you have to solve and sketch the function. F of x is equal to x square, x lies between minus 1 to 1. It means on x-axis you are taking the point minus 1, 0 and 1, and then sketch the function and see whether it is even or neither even nor odd. According to that, find the Fourier series. Similarly, this function 1 minus x square by 4. So the range is minus 2 to 2 is given. So on the x-axis you are putting minus 2 here, and then 0, then 2, and see what the graph looks like. And after sketching the graph, see whether it is even, odd, neither even nor odd, find its Fourier series. I have given 2L is 2, so it means L is equal to 1 here, L is equal to 2 here, and this is the function. Graph I have given, this point is 4, 0, and this point is 0, 4, x is 0, y is 4. So you are looking at the graph and see it is an odd function, but find the equation of this straight line, which is this straight line. Find the equation by using 2 points law formula, and this is 2L is equal to 8 because this is the total period, which is 4 and 4, 8. So it means L is equal to 4. Find the equation of this line, which is going to be y minus y1 is y2 minus y1, x2 minus x1, x minus x1. This is the 2 points law formula. So this is x1, y1, this is x2, y2, putting the values and find the equation of the